Hello, my name is Siddharth Jain. This is the video presentation for the Integrated Electronics project. The name of my project is Implementation of 4-bit ALU using Transistor-Transistor Logic incorporating OPCODE. I have designed this ALU from scratch using only transistors to implement the core logic of my circuit architecture. The main problem statement is ALUs are the core area for mathematical operation. Hence, I was looking for techniques to increase the area efficiency. My main motivation is to reduce the area occupied by the transistors considerably, keeping the functionality as it is. This is the overall abstraction of the entire ALU. ALU consists of the adder subtractor combo circuit. This is one of the novel features of my project. The logical unit, the shifter, another novel feature of my project, and the mux, whose output is dependent on the opcode that we provide, and it has three status flags: an overflow flag, a zero flag, and a negative flag. This is my 4-bit adder subtractor combo circuit, one of the novel features of my project. It consists of four 1-bit adders connected to each other via the carry, thus making this a ripple carry adder. These transistors here are the gates itself. This is the XOR gate, OR gate, NAND gate, AND gate, and the OR gate. It has three status flags: overflow, zero, and negative. And the reason why this circuit fulfills the goal of decreasing area is because I can compute these two's complement on the fly. So by choosing the mode 0 for addition and 1 for subtraction, I can instantly compute these two complement and add that to A, thus doing subtraction operation. This eliminates the need for a separate subtractor circuit, hence increasing overall area efficiency. In implementation was to create these gates using transistors, and in combination we can make these transistors to function as gates. Here, this is the NAND gate, this is the NOT gate, this is the shifter I have made. The shifter again using the AND gates and the OR gates I used before, I have made the shifter. The shifter again is one of the novel features of my project. By using again another mode select, I can considerably reduce the need of the area to make another shifter. So this shifter shifts between left and right. The overall architecture shifter is designed like this. This is the logical unit. Again, using the NAND case that I showed before, I have implemented a logical unit that gives the AND output, the NAND output, the OR output, and NOR output. And as we can see here, all the components that I just showed are made in combination. Given to this mux and given the opcode that we give, we can get the corresponding output. I will now give the demo. As we can see here, this is the opcode for the various functions. We can see that these two inputs are being added, and this is the output. The overflow flag is on because of the overflow being taken place. And as we can see, if we flip through these numbers here, we can see that the output itself are what we expected. For AND gate, NAND gate, or NOR, and shift left. Shift left works only on the A input, and this is shift right. I will now talk about why I chose Logisim as a simulation tool. Logisim is a great tool for designing and simulating digital logic circuits. With the capacity to build large circuits from smaller subcircuits, like I showed with the adder, shifter, and the logical unit, and to draw bundles of wires with a single mouse track, Logisim can be used to simulate entire CPUs. I have only designed a small ALU, but this similar procedure can be done to design entire CPUs. One of the great projects of Logisim is the ability to prototype with already built-in gates and shifters, and then use that same functionality to test my own parts. The sub-circuit feature of Logisim allows me to reuse circuits instead of designing it all on its own, hence giving the hierarchical circuit design that is included in a lot of industry projects. The included combination analysis module allows for conversion between circuits in truth tables and Boolean expression. This is essential for me in order to debug my circuit. In conclusion, I have talked about my problem statement to reduce the area occupied by the transistors. My implementation details was using the transistors. I had mimicked the operation of my various gates and used those gates. My novel feature was the inclusion of the adder subtractor combo and the inclusion of a logical shifter. Thank you very much. That was the end of my presentation.